SpaceX IPO is not really a rocket story. It is a bet on where AI will physically live next. That is the counterintuitive promise here. The market may not be paying only for launches, satellites, or Starlink. It may be paying for a possible answer to one of the biggest questions in the AI economy. If every AI company needs more compute, and Earth-based AI data centers run into power, cooling, land, and deployment limits, who controls the next place where compute can run? That is why the SpaceX IPO matters now. SpaceX raised $75 billion in the largest IPO ever. At pricing, the company was valued around $1.77 trillion. But Reuters also reported that SpaceX had about $18.67 billion in revenue in 2025 and a net loss of $4.94 billion. That gap is the story, not because it proves the valuation is right, not because it proves the valuation is wrong, because it tells us what the market is trying to price. In the next few minutes, the question is simple. Is SpaceX AI compute a real value shift or just one of the most expensive infrastructure stories in the market? The test is this: path, not proof. SpaceX is selling a path. The market is pricing the path. But the business has not proven the outcome yet.
So the point is not whether people should buy the SpaceX IPO, avoid it, or call it a bubble. The opening number is huge, but the number alone is not the value shift. The point is more basic. What future bottleneck is the market trying to price? And why would a rocket company be part of an AI compute story at all?
Yes, and that future bottleneck begins with something very physical. AI compute is becoming physical. For years, the AI story sounded digital: models, chips, cloud contracts, software tools. But behind every model is a machine. Behind every machine is an AI data center. Behind every AI data center is power, cooling, land, water, fiber, transformers, permits, and time. That is the part many people ignore. You can announce a model in a week. You cannot always build a large AI data center, secure the power, cool the racks, and connect everything in a week. That is the AI infrastructure bottleneck. And that is where SpaceX becomes more interesting than a normal rocket company. The surface headline is SpaceX IPO. The deeper headline is SpaceX AI Compute. The question is whether SpaceX can use Starship, Starlink, satellite manufacturing, and launch scale to create a new geography for compute. Not on Earth, above Earth.
That sounds like science fiction. And for a normal viewer, the default reaction is probably simple. AI runs in data centers. Rockets put things in orbit. Those sound like separate businesses. So the question is not launch hype. It is whether AI is running into a physical wall on Earth. What connects them in the story?
The connection is capacity. If ground AI data centers are constrained by power and cooling, then orbital AI compute becomes a possible escape route. Possible, not proven. Possible. And in markets, possible control over a future bottleneck can become valuable before the bottleneck is solved. The market is not waiting for a perfect orbital data center business. It is paying for the chance that SpaceX might own a path others do not. Think of AI like a factory. For years, investors focused on the machines inside the factory, the chips, servers, models, and cloud platforms. But if the factory runs out of electricity, the machines are not the whole business. Suddenly, the valuable person is the one who controls the site, the power line, the cooling design, the delivery route, and the replacement cycle. In normal AI infrastructure, that gives power to cloud companies and data center operators. But SpaceX is suggesting a different map. What if one part of future AI infrastructure does not have to stop at the data center wall? What if the stack includes the grid, the launch pad, the satellite factory, and the orbital network? That is the value shift. Not cloud to space overnight. Not NVIDIA is doomed. Not AWS or Google Cloud suddenly become irrelevant. The shift is narrower and more useful. Value may move from simple cloud capacity to control over the physical paths that make compute possible. Power, cooling, location, launch, network, replacement. Those 6 words are the real story.
So SpaceX is not trying to replace every cloud data center. It is trying to convince the market that it could control a new physical path for some future AI capacity. That is a much narrower claim, but it is easier to test. If that is the claim, then Starship, Starlink, and satellites become parts of the same capacity chain.
And the path starts with launch. If you want orbital AI compute, you need cheap, frequent, reliable access to orbit. That is why SpaceX Starship AI matters as a business phrase, not because every viewer needs rocket engineering, because launch cost decides whether orbital compute is a business or a slideshow. Then comes the satellite layer. SpaceX has described an AI satellite concept that would use mostly existing Starlink V3-related technology. The design points to solar power and heat radiation. Reuters reported that the first AI satellite would aim for about 120 kilowatts of sustained compute power, similar in scale to a high-end NVIDIA server rack. This is where the story becomes easier to understand. The pitch is not one magic satellite replacing an entire AI data center. The pitch is modular. Put server-like compute into satellites. Launch many of them. Connect them through the network. Try to create a new class of AI infrastructure. That is why phrases like Starlink AI and orbital AI compute are showing up in the same conversation. They are pieces of one infrastructure path. But here is the first major turn. Space power is not unlimited. Space cooling is not free. Remember that line, space power is not unlimited. Space cooling is not free.
That is probably the biggest misunderstanding. People hear space-based AI and assume solar power solves energy and vacuum solves cooling. But if heat still has to leave the system, hardware still wears down, and satellites still need replacement, then the pitch is not automatically an economic model.
It is not. Those phrases may make a great pitch, but they are not a business model. In orbit, heat still has to leave the system, hardware still wears down, radiation still matters, satellites still have lifetimes, launch still costs money, communications still have limits, customers still need workloads that make sense in that environment. So the real question is not, can SpaceX put computers in space? The real question is, can SpaceX make orbital AI compute commercially useful enough to matter? That is much harder. This is not a hype video. It is also not a bubble video. The stronger frame is credible direction, unproven economics. Both can be true. SpaceX has real advantages: launch experience, satellite manufacturing experience, Starlink's global network, a brand that can raise capital at enormous scale. But advantages are not outcomes. Path, not proof. Advantages, not outcomes. If this works, the value shift could be large. AI labs may have another path to capacity. Cloud companies may face a new kind of infrastructure rival. Chip companies may eventually need to think about systems designed for orbit, not only racks on Earth. Infrastructure investors may start valuing launch, power path, cooling design, and orbital networks as part of the AI stack.
But the counter-argument is strong. Ground AI data centers are not standing still. They are easier to maintain, easier to upgrade, and already connected to cloud customers. They may be boring, but boring infrastructure usually wins for a reason. The counter case is that the old infrastructure adapts faster than the new one becomes economical. Why would orbit beat that?
That is the useful pushback. Ground data centers are boring, and boring is powerful. They can be serviced, upgraded, insured, and financed. They can replace hardware faster. They can connect to customers with lower latency. They already sit inside cloud ecosystems that enterprises trust. They are also improving. Liquid cooling, cheaper power locations, new energy deals, better chips, better data center sites, and better utilization all matter. An orbital AI data center has to beat more than physics. It has to beat the economics of boring. That is a very high bar, so the market story only gets stronger if ground infrastructure stays constrained enough for a new compute location to matter. SpaceX does not need every workload to move to orbit. It does not need ground cloud to fail. It needs a slice of AI workloads where the constraints on Earth are painful enough, and the orbital path is useful enough for customers to pay. That is the commercial test, and that brings us to the time anchor. The next 6 to 18 months matter because this story has to move from investor narrative toward evidence. Reuters reported that SpaceX executives describe plans for initial space-based AI computing demonstrations by late 2027. If those demonstrations slip, shrink, or stay vague, the market story weakens. If they happen and show real compute, the story gets stronger.
So the viewer should not watch this like a stock chart. They should watch whether the infrastructure path becomes real. A demo is not the same as a customer, and a benchmark is not the same as a business. What signals separate the story from the shift?
There are 5. First, demonstration. Does SpaceX move from investor pitch to visible space-based AI computing tests? Second, launch cadence. Orbital AI compute only makes sense if hardware can get to orbit often enough and cheaply enough. That means watching Starship reliability, manufacturing speed, and repeated launches. Third, workload. Does a paying AI customer want to use that compute for a real task? Fourth, unit economics. How long does the hardware last? How much compute does each satellite deliver? How much does it cost to launch, operate, replace, and connect? If those numbers do not work, the story stays a premium narrative. Fifth, the ground response. If Earth-based AI data centers solve power and cooling faster than expected, orbital compute becomes less urgent. If chips become far more efficient, the pressure drops. If new power comes online faster, the bottleneck moves again. That is the reversal condition. Now, there are three ways this plays out. Base case. Orbital AI compute remains a strategic option. SpaceX proves enough to keep investors interested, but most AI workloads stay on Earth. The value shift is real, but limited. Acceleration case. SpaceX launches credible demonstrations, lowers launch costs, shows usable compute, and signs customers for specific workloads. Then the market starts treating orbital AI infrastructure as a serious part of the AI capacity race. Reversal case. The engineering works in headlines, but not in economics. Ground AI data centers improve. Customers do not move meaningful workloads. Launch delays continue. Then the SpaceX IPO looks more like a huge premium for a powerful future story than a completed value shift.
So the final question is not, is this genius or hype? It is, what bottleneck is the market trying to price? And just as important, what would prove that the market priced the story too early, before the infrastructure is actually useful?
That is the useful question. For SpaceX, the answer is getting clearer. The bottleneck is not only getting to space, it may be creating new physical capacity for AI, power, cooling, location, launch, network, replacement. That is the map. That is why the SpaceX IPO deserves attention, not as stock advice, not as a Musk biography, not as a Mars story, as a signal that AI infrastructure is becoming a physical control game. When everyone wants more compute, the winner may not be the company with the best demo. It may be the company that controls the hardest place to build. And right now, SpaceX is asking the market to believe that one of those places is orbit. Maybe that belief is early, maybe it is too expensive, maybe it is partly hype, but it tells us where the next fight is moving. The fight is moving from who has the best AI story to who can build and control the infrastructure that lets AI scale. That is why SpaceX AI compute matters. That is why orbital AI compute matters. That is why the AI data center story is no longer only a ground story. And that is why Starship and Starlink now sit inside a bigger AI infrastructure question. SpaceX record IPO may be remembered as the moment public markets started pricing compute geography, not just chips, not just cloud contracts, not just models, the physical places where AI can run. To understand the AI economy, do not only follow product launches, follow the bottlenecks, gatekeepers, profit pools, and strategic control points behind the AI economy, because the headline is temporary, the value shift is not.